Let's discuss the preparation of primary amines by gabriel phthalimide synthesis. Okay, so here the phthalimide we are going to use as a substrate one, and we are going to use alcoholic potassium hydroxide solution. So via SN2 mechanism we are going to get the product as a primary amine. So SN2 means substitution nucleophilic reaction. First we should take the phthalimide as a substrate one. So I write the first structure phthalimide. So this is called phthalimide structure. This is called phthalimide structure. We are going to use the alcoholic potassium hydroxide solution. That is nothing but KOH. That is nothing but KOH. So KOH. So I write the charges also. K is K plus. This is OH minus. And you know very well that KOH and NaOH we can take use here. So NaOH and KOH both act as a base, and the base work is to abstract the proton. Okay, abstract the proton. Where? How? That is called acidic proton. It is always abstract the acidic proton. Acidic proton here. So here hydrogen will be there. Okay, what happens? This is hydrogen. So it abstracts the hydrogen. So this OH minus, which this acts as a base, right? So after this reaction, water can be eliminated. Water can be eliminated. So here OH minus and this is H plus. Water can be eliminated. But here what happens? The bond here, nitrogen and hydrogen bond will be there. While leaving hydrogen, which goes out as a H plus, and here this bond gets towards the nitrogen atom. Why? Because the electronegativity difference between nitrogen and hydrogen. So nitrogen will be more, so which abstracts the bond pair of electron towards this nitrogen. Then it becomes N minus. Okay, N minus, and this is a plus. So this minus and plus forms the potassium phthalimide. So now I am going to write as after the removal of the water molecule. So now it is called potassium phthalimide salt. So this is potassium. How it forms? K plus with N minus. This is for salt formation, and here OH minus and H gets eliminated as water. So this hydrogen element as a H plus. So it making a N minus, and this H plus OH minus combines to give the water molecule. So now this is act as a nucleophile. I told that SN2 is nothing but substitution nucleophilic reaction. So I am going to use here alkyl halide. Why I am going to use alkyl halide? Because our aim to find out the primary amine. So primary amine function group is RNS2. Now I got R here. I require NS2. Okay. So what happens? This is substitution. This act as a nucleophile. So and also I write it as a X is a halogen groups. I told that X is a halogen groups. So they have the partially delta negative charge and delta positive charge of the alkyl group. Why alkyl group? Because the carbon. Alkyl group is nothing but carbon atoms will be there. So difference between bond difference here, hydrogen will be having the more electronegativity. So just I mentioned here delta minus and delta plus. So this nucleophile obviously which attacks towards this opposite charge, that is called alkyl group. So what happens? This nucleophile attacks with the alkyl group, and because it is slightly positive in nature, it is positive and negative. Okay, it forms the bond, and here this X minus eliminates. X eliminates as X minus, and act as X minus, and now this X minus because it abstracts the bond pair of electrons. Now it becomes X minus, but whereas here K plus will be there. Again there will be charge opposite. Then for salt will be formed because of the opposite charges. Now I write Kx like this because now bond is formed. K plus X minus they combined as a salt formation that I have removed now. So now I am going to write as now this is N-alkyl phthalimide. That is called N-alkyl phthalimide. N-alkyl phthalimide. So now, so in order to get the primary amine, that is RNS2, now I have Rn I got, remaining hydrogen I require. Okay, so like this mechanism will continues via SN2 mechanism. So now I am going to take here once again KOH, alcoholic potassium hydroxide solution, and you know very well that so this KOH you know very well base, and base work is abstract the acidic proton. But can you see here any acidic proton here? No acidic proton. That's why now it acts as a nucleophile. So nucleophile. This acts as a K plus and this is a OH minus. then this nucleophile where it should attack. So I told that this is a carbonyl function. This is what? Carbonyl function. We should write that carbonyl function always. We are writing this is a delta plus charge and this is a delta negative charge. Why? Because the oxygen is more electronegativity than carbon atom. So which abstract the bond pair of electrons. After this bond pair of abstraction, then it becomes O minus and this becomes C plus. So that's why here this OH minus group which attacks to this carbon. And it may attack also here, no problem, because the both priority will be there. Okay. Now I am showing here in this carbon. So what happens when this nucleophile attacks to this carbon atom? Now the carbon becomes pentavalent. But you know that pentavalent it is not stable. Our carbon length is 4. What happens? This is a 5 bonds. 1, 2, 3, 4. This is a new bond. 5 bond. What happens? This bond will get migrates towards here. So now it becomes O minus. So this is a new bond. OH group is attached to this carbon function. Now it becomes O minus. After this O minus, what happens? In order to get the stability, again this is a back donation. This is called back donation bond. After this, giving this back to this one, so this bond will be shifted here. Because to maintain the stability of the carbon atom, because that is a tetravalency. So when this OH minus group attacks to this carbon function, then it becomes 5 bond. In order to maintain the 4 bonds, this bond carbon and oxygen, whatever it abstracts the bond pair of electrons, then it becomes O minus now. Now CO minus and new bond OH group. What happens? Again oxygen gives the back donating bond. So this O minus turns to the double bond and this bond gets eliminated. So now I am going to write as it is. Similarly, so it's a double bond as it is there, and new connection is OH, that is nucleophile. Now it has attacked here OH and remaining it migrates here because the electronegativity difference between nitrogen and carbon. Nitrogen is having more electronegativity, that's why it abstracts the bond pair of electron towards itself. So now it becomes N minus. Okay, now it becomes N minus. So this N minus, now we are in the position to take the hydrogen group. So that is here. This step is called hydrogen shift. This step is called hydrogen shift. So here what happens? This hydrogen goes to this nitrogen atoms because you know that always C double bond O minus will be more stable than the COOH. Here COH will be there. So in order to get the stability, it forms the COO minus. When it will be for CO minus? When it donates this hydrogen atoms. Okay. So similarly here hydrogen will connect to this nitrogen atom. Then it abstracts the bond pair of electron towards itself. Now it becomes O minus. After the removal of this bond, because this hydrogen has shifted to nitrogen atom, right? So this bond comes here O minus. And what happens? So that we have used K plus. This will be remaining as it is. This K plus which combined with O minus. Okay. So I write this step also. Okay, like this we got, because this hydrogen has shifted to nitrogen atom with the mechanism. So till we got here, so what happens? Our aim is to produce the RNS2 group. So once again, I am going to react this with potassium hydroxide solution. That is KOH solution. Once again, here there is no what happens? This OH group which attacks as a nucleophile. So similarly, so I am doing like this K plus and this is OH minus. This OH minus will attack with this carbonyl function. Okay. Similarly, as we can see in the previous steps. Okay. So what happens now? This is I am going to further next step. Okay. So similarly, I have written as it is NHR and OH group is attacked now here. So this is why, because it is always on the stable. Okay. So now this is a back donating bond once again, because this is unstable compound. So after this back bonding, what happens? So now carbon becomes 5 bonds. 1, this new bond, 2, 3, 4, this will be 5 bond. So our aim is to produce RNS2. So everything will be ready is there. So what happens? The bond will be shifted towards the nitrogen atom. How it has shifted in the previous steps we have seen that. So electronegativity difference between carbon and nitrogen. Nitrogen will have the more electronegativity. So it obstructs the bond pair of electron towards the nitrogen. Now it becomes C double bond O OH as it is. So what I have eliminated here? RNH minus. Now what I have eliminated here? I have eliminated here RNH minus, because nitrogen is a trivalence. Okay, so 2 bond will be there. Okay, so now when bond towards like this, nitrogen gets a negative charge. What I want remaining? Hydrogen I require. So who will be giving? This will be given because of the stability. So COO minus will be more stable than the COOH. So once again, which obstruct this bond pair of electron towards the oxygen, hydrogen will be eliminated. Hydrogen will be eliminated as a H plus ion. So now this H plus ion will come and attack this nitrogen. Okay, this hydrogen come and attack with this nitrogen to form the RNH2, and remaining I am going to write as this, and this is now become CO minus, and this CO minus will combine with this K plus, remaining K plus. So I am writing the final steps. So we got now RNH2 group. This is called our primary amine. So this is called primary amine. So like this we have prepared this primary amine by using the gabriel phthalimide synthesis via SN2 mechanism. Yeah, SN2 mechanism. So this is a very important reaction, and as well as important mechanism. It's a very beautiful mechanism to practice.